this structure is based on the primary vehicle design. All the suspension loads go through here.
Yeah.
So we're trying to get our torsional stiffness from this. We're also supporting the bed loads. It's 2,500 pounds. And the towing loads, which is 11,000 pounds. And they all go through here. When you put all that math together, right, then you end up with sort of like an elegant load path structure of trying to get back to our nodes at the batteries and the corners and from back here. Then the crash really just becomes a fallout of how do I keep that stiffness where I need it for all those loads to be distributed, and then what can I absorb, when I get hit from behind. But crash is actually the simple part of these designs now.
Hey boys and girls, welcome back to Munro Live. I'm here with Jordan, and today we're going to have a look at some of the skins. This is the rear fender, or could be called almost a quarter panel, but it's going to be the rear fender for today. Jordan has had a whole lot more experience on this than I have. The only thing I can tell you is that that is not powder coat. This would be E-coat, and I love the Easter eggs you pointed out. Even this cutout here, it's kind of cool. And we are looking at steel, magnet steel. So the deal here is Jordan is going to be probably doing most of the talking. Why don't we start with why there's little bumps in here when you're fooling around with E-coat?
Yeah, so if we look at this whole thing to orient everyone, this is the rear body side of the Cybertruck. So behind us, you can look here. This is the big stainless panel that would bolt onto the side of this. So this is the wheel arch cutout and so forth. So we're looking at the inboard side of it. So on the outboard, we've got the stainless. Inboard, we've got stamped steel, all E-coated stamped steel subassembly. And it is E-coat, right? Because you can see the difference between an E-coat, nice shiny coverage, versus something like they do on the rear, which is like kind of a matte finish powder coat. So this is just appearance for blackout, right? So that when you open the tailgate or something, you're not seeing this sort of green colored E-coat. But talking about the assembly here and what we saw when we removed it from the vehicle, clearly they're using this whole inner assembly to garner back quite a bit of structure. So it's all using some structural adhesive, some bonding to the parts below it. And you'll see, I want to point out a few unique features as we go through this. But maybe we'll start with this. You might look at this and say, well, why would you put like a weird flute here? Why would you open up a gap right here? Why would you have another kind of opening at the bottom here? That's because this is a multi-piece subassembly that gets brought to the vehicle as likely one large piece.
Yep.
And since this is a subassembly, the whole thing is going to go through an E-coat dip or a bath all at one time. And when you do that, you can't have any of that E-coat, that liquid, get trapped in any one of these cavities. You need an escape path. So when you see, often when you see unique paths or weird, orifices in an assembly like this, you got to look at E-coat first and foremost to figure out, is that an escape path? If you look closely at most body in whites, unibodies, you'll see any number of escape paths like that. For this one's a little unique.
Yeah.
So you can see that this one, there's two telltales that to me say this is probably not just E-coat. In fact, it may not be E-coat at all, drainage.
Yeah.
So one is the fact that it's slightly proud, it's taller relative to this flat surface. And two, and this is the dead giveaway, you've got two spot welds. So if you notice a moment ago, I had said this whole assembly is using structural adhesive to bond to the stainless. Well, here they've got spot welds, which means that they're not going to the stainless on the outboard side. What this is an additional layer of the stamped steel below it, coming all the way to the flange here. So that's an additional section here. So
well, it's a stiffener. It's a stiffener, and there may be another reason, and it's hard to say because, quite frankly, we don't know everything about this, but it could be for thermal expansion as well. Every once in a while, when you have dissimilar materials like the stainless to this mild steel, you're going to have situations where it needs to breathe, and that could be something there. It should have been closer to the center for that, but it's probably close enough. But at the end of the day, something maybe here that it would cause a hum or some kind of rattle or whatever. There's a lot of reasons for putting a stiffener in here and not all the way across, because it's obvious that whatever's in here is only in a small area.
Thanks to the Three-Dimensional Services Group for sponsoring this video. Whether you're looking to source metal stamping, precision CNC machining, laser cutting, welded assembly, or plastic injection molding, the Three-Dimensional Services Group should be the source to transform your EV, aerospace, appliance, or technology designs into reality, while also providing a bridge to start of production.
Hey boys and girls, I'm here with Dan, and we're at Three-Dimensional Services Group. And Dan, this is pretty impressive. Why don't you give us a little background on what you guys do here?
Okay, well, the Three-Dimensional Services Group was founded by Douglas Peterson 31 years ago. We've grown into the world's largest, most capable, and most agile prototype and low volume manufacturer. In essence, we're a job shop on steroids. We work with the world's most innovative companies to validate their designs, and then we're able to take our low volume manufacturing processes and scale them across a massive amount of equipment to allow us to support volumes that a traditional prototype shop would never be able to support. We're always working with our clients to accelerate their product development timelines and enable them to be as successful as possible by bringing their products to market as quickly as possible.
Now, this whole assembly for me, I know when we got all the original images, even years ago, started coming through on the Cybertruck, the castings and all the structure underneath. This is the answer to many of the questions that I had leading up to it, which is, how in the world are you going to efficiently, or in any way for that matter, attach a giant brake bent or stainless steel panel that's so thick where you can't really get the same types of flanges and unique geometry, not easily anyways, that you can with this stamping. This sub-assembly is doing the work of most of that interface to the castings, right? So not only is this providing a pretty significant measure of stiffness on this panel, like torsionally speaking, it's also providing all the interfaces, some of those more acute geometries that we're seeing in the rear for the liftgate attachment, right? Some of the latching interior panels and so forth. So this panel right here is doing quite a bit of work, and it's really the enabler on the outside of the vehicle to get that nice smooth appeal. And really this is the guy doing a lot of work to make sure as much as possible that we're not getting a lot of weird rippling or warping on this stainless panel. So if you look down the side of the vehicle, you know, you don't want to see a potato chip, right? That's bad. There's a lot of work that's going into the differences in thicknesses, where and how they're attaching it, the spring back, all the rest to make sure that this panel is nice and straight and flat. And
this is what kind of you could call an exoskeleton. So I've been critical saying this isn't an exoskeleton vehicle. Obviously you can see there's a skeleton, but in this case, the exoskeleton is needed in order to keep all these chunks of stainless steel flat and you know, and keep them there forever. Even though this is very thick and whatnot, it has no strength compared to what you're looking at here. Yeah. So, by the way, the other thing is, I think you already mentioned it. This this stainless steel is actually glued. These two parts are glued together. Yep. And we found a little point where you can have a look at it over here. Normally we do not like to bend things, but this has already been scanned, so we're good. But you can see we got a little lump of that. So we will be giving that to our adhesive chemists, and they will be telling us what the heck, what all this thing is about. Why don't you talk a little bit about the laser welding, and then we can get into it.
Yeah, so on this upper flange, which would be the bed rail, right? If you're walking up to the side of the truck, this whole zone right here, if you look underneath, you'll see some weird lines. Those are laser welds. So they're linear in some cases. You know, we're seeing a little bit of variation, right? Not perfectly straight, but it could be just because they're running them fairly quickly and they don't care if they're perfectly straight or not, because As long as they're there, they're doing the job. The odd thing about these laser welds is they're incredibly, the way that they're laid out right now, all in linear fashion like this, it makes the joint, you know, strength in this panel versus this one incredibly strong in the fore-aft direction. So essentially along the axis of the weld, you've got a lot of surface area that's really going to give you a good weld bond versus just a cylindrical spot weld. The downside to that, and largely the reason that you're seeing some of them be staggered a little bit, is you do lose some shear strength. Yeah, some shear strength in the other direction. So it's hard to say. There's a lot of advantages to laser welding, but this one may be laser welded due to spot weld gun access, how the assembly came together. I'd want to get this extra layer off and look at the underside and see how it's put together. But that could be one of the reasons that they'd go to a laser weld. There was a couple spot welds down here, but maybe Grace, if you want to come in. There's a ton of them over there. There's a whole bunch of examples down here, right, where they're able to get some good solid spot welds from panel to panel. And you'll see from a standoff perspective, you don't want the panels to be touching 100%. That can give you dimensional issues and all sorts of weird things. So where they want to touch down and weld, they give themselves a nice flat. They stay away from the radii, right? Keep those spot welds in a nice flat surface, good index, and they'll spot weld anywhere that they really need to, even the small brackets down here, for example.
And you'll notice too, like most people are not really terribly familiar with how spot welders work, but they're like a big pincher. And so you've got to have room to get in and spot weld if you're going to be doing something like I'm taking this piece and I'm welding it to that piece. You have to be able to access them. One of the nice things about lasers, I don't need anything. I can shoot right through them, and that to me is why I prefer spot welds only if I can't find any other way of doing it. They're the cheapest to put out, but there's a lot of maintenance associated with it and other things. I really like, my guess is that this is a Trump laser, and I like their lasers, and to me, if I was going to be into creating a factory and I had to choose between 4 or 5 different kinds of spot welds, or actually 3 or 4, and a multitude of options I've got with laser welding, I'd probably choose laser.
Now let's look at the castings a bit. So when we looked at the 2022 Model Y and we looked at the first Giga casting, one major thing that changed was not just the casting, it was the bill of process and the whole GD&T, so geometric dimensioning and tolerancing strategy. How they actually allowed and restricted cross-car slip and movement from an alignment perspective. The Model Y was the first vehicle that we saw come in from Tesla, where at the bottom of the vehicle it was locked in, meaning there was no adjustment left available cross-car. We're seeing a similar thing here. The telltale is there is no layered panel or cross-car slip available, no flat surfaces that would allow you to freely move in the y-axis for you CAD spinners out there. At the major structural interface between the occupant home, this multi-piece stamped steel assembly, and the Giga casting. They actually use, which is not actually commonplace for Tesla on their castings, but they use a few SPRs, some structural adhesive, and a few other things to attach those. But what they're doing in essence is they're saying the castings are the first to go in the line, and that is going to lock in the entire vehicle's base, the underpinnings, dead nuts, and the y-axis.
In other words, the castings are now the fixture. So normally people buy fixtures. These guys, what they do is they cast fixtures and they utilize them for the rest of the body build. And I think, and I've said this about a zillion times, I've been a big fan of casting. I had that one sitting on the floor for 15 years. I know that this is the right way to go because I don't want to buy 1,000 fixtures that always go out of spec.
And tolerance.
This and tolerance. And this is a big thing. Tolerance stack up is the killer. The older a body line is, the worse the tolerance stack ups are. And so that's where you get things that don't fit, or worse yet, they fit in such an ugly way that you can see them from the moon. So this is a very, very smart way to make things happen. Let the castings be the fixture and let me use that to build everything else from it. Perfect. And you never lose the fixture. It's always here.
Now, They didn't say, hey, we're going to lock it in at the bottom and we'll never adjust anywhere else. They still smartly, right? And I think necessarily, they left themselves some opportunity to do some of that cross-car slip, just like the 2022 Model Y. So as we go upward in vehicle and we look at the extra castings that they've got that make up the whole upper structure of the vehicle, you see that this piece is not a casting, it's a stamped panel. And it's an interface between the major lower giga casting and this upper cast piece. And so what I believe that they're doing here, notice it's a flat surface, here in the back where these two other castings come together, right? So this flat surface here. And then also down below where this casting mates up with the major lower casting, there's a common theme here. They got flat surfaces on all three of them. So more than likely, as we were talking about warping and that sort of potato chip thing on the body side outer subassembly, in order to make sure that that thing is not cattywampus relative to the vehicle, right, that everything is true, the tailgate fits properly, they can control those gaps, they're allowing themselves some cross-car slip, some adjustment via some of these flat surfaces. It's not a lot, right? They're probably not moving this multiple millimeters. But a fraction of a millimeter is what we get into in terms of tolerancing.
So before we move off of what you just said, Grace, can you come around here? And I want you to pretend you're shooting a deer, okay? I want you to look at this line right here, all the way through. You're going to be looking at something that is about as straight as a die as you can possibly get. This is a very, very difficult thing to do in a normal pickup truck. To get the box so that it's square to the world is near impossible. And when you see this line as straight as what I was just looking at a second ago while Jordan was talking is almost miraculous. So here's a spot weld that it was invented, I think, by General Motors, and it's a concentric spot. So you got aluminum to aluminum. These kind of spot welds are unbelievably strong. General Motors did a good job in inventing that.
Yeah, and actually, Sandy, to your point, it's a slight twist from what they did because General Motors, their version of it has a bunch of rings in it. If you remember,
that one's got rings too.
This one doesn't have the same rings though. So if you looked at a CT6 or any of General Motors spot welds, you'd see some very crisp circles. And what that was allowing General Motors to do is reduce the number or increase the number of spot welds that they could get before they had to redress the tips.
Exactly.
Right. I believe it was on the order of tripling the amount of spots that they got. So I don't know if Tesla did a variation to that or what have you, but I will say this. Not only to spot weld two castings, so that's interesting, they also spot weld a stamping to a casting, and it's like, wow, okay, that's cool too. The wild part is they're spot welding both of those right through structural adhesive.
Yeah. And I thought that was the main reason for the extra circles, if you want to call them. It was because now I can penetrate a whole lot better. Like giving yourself a nugget, that's what that's called. Mm-hmm. And this is like, is this a T2 or a T3? Is there 3 in there? No, there's only 2. So this is a T2, 2 thicknesses that it's welding through, I think.
I think you're right.
Yeah. And that means that, for that thickness, that's going to go for quite a while. That's a lot of energy that has to go into those resistant spot welds.
Yep. Yeah, and you can see, like this dimensional topic. You might just look at castings and be like, wow, tons of ribs, lots of engineering. But this whole dimensional GD&T topic is a phenomenally difficult and specialized practice where if done wrong, you can take the best concept or design in the world and you can release a vehicle off the line that's barely worth driving.
Looks like a banana and drives like a dog. Yep. And that's kind of one of the reasons why so many people spend so much time on the assembly line trying to make sure that from a dimensional stability standpoint, you've got to have everything on your side. Yeah. Not one thing or two things, but everything. And looking at this just makes me happy.
Yeah. Ordinarily, if you were to draw an analog to a stamped assembly, right? I'm counting 1, 2, 3, 4, 5, 6, maybe 7. 7 parts per side on this sub-assembly, major parts. If you were to look at a stamped equivalent, you're looking at 100 parts.
Easily.
Right, so you might say, man, that's a lot of parts to align. This is like putting Legos together, relatively speaking, in terms of the intricacy and the amount of GD&T and fixturing and so forth that you'd have to go through. So quite a bit simplified, although, you know, perhaps if you've never seen a body structure or something, you might still think there's a lot going on here. This is quite simple.
It is. It's about as simple as you can possibly get, and it's certainly it's certainly simpler than what we would normally expect to see out of anybody. I don't care who it is. This is. I do gush a bit about what's going on with Tesla. I just like the fact that, you know, we have a lot of rules when we tell people how to design their products, and it's nice to see people that have actually taken those rules and put them into effect.
Yeah, I mean, there's certainly, no one's without their issues. There's certainly, they have struggles with certain things, just like any OEM, but you have to appreciate the fact that they're just gonna go for it.
So anyway, this vehicle is going to have the, after it's done gauged, the scanning and whatnot, after it's out of the gauge, then what's going to happen is all these panels are going to go back on, and the body is going to go for nodal testing. And that means that, not us, because we haven't got any equipment like that, the whole body will go into basically a giant fixture and it'll go, and they'll do everything they can to see how stiff the body is. And that'll be measured in hertz. And when we find out from our new best friends down the road, then we'll let you know. So with that, Jordan.
Thanks, everyone. Reach out at sales@leandesign.com if you have any questions. Appreciate your time.
Bye.